Hey everyone, welcome back to my channel, and in today's video we're going to keep building our Telegram bot from scratch using the Aiogram 3 library. But before continuing, I would like to remind you that we have a Discord community and you can find the link to that one in the comment section below. I will also leave a link to the GitHub repo that I'm going to use in this episode. Without further ado, let's get started. So I recently got a question from one of you asking to explain the difference between long polling and webhooks, or more generally, how does your bot actually work when it receives new updates from Telegram? So to answer this question, we first need to understand what is the long polling and the idea of polling in general. Polling is just a way for your server to communicate with Telegram API. If you want your bot to know whether there are any new updates, whether a user has sent a message to your bot, your server has to explicitly ask the Telegram API for those updates. That's how your bot stays aware of anything new happening on the Telegram side. So long polling is basically this process of asking the Telegram API for new updates. If there are any new updates, say a user has sent a message to your bot, then the next time your server asks the Telegram, the API responds with something like, yes, there is a new update, and here's the message content. So your bot is periodically asking the Telegram servers at specific time intervals, hey, do you have anything new for me? There's also a timeout. After some period of time, if nothing happens, the connection is closed and a new one has to be opened. The nice thing about long polling is that it is very easy to set up to get started with. You don't need a public URL, it works perfectly fine in localhost, and you can start developing your bot right away. But the downside of this approach is that it is not very efficient. It keeps an open connection and essentially runs in an infinite loop, constantly asking Telegram API for new updates at the fixed intervals. But in contrast, we have webhooks, which you can think of like a doorbell. And here's how it works. So you give the Telegram API a public URL. Whenever a new message arrives, maybe a user sends a command or clicks a button, Telegram API sends an HTTP post request to your server. That request contains all the information about the new update. So now your server doesn't explicitly and constantly ask the Telegram API for new updates. Instead, Telegram will push any new updates to you as soon as it happens. And this is very efficient because now there are no idle checks. If nobody messaging your bot, your server doesn't do anything and it just sits quietly there and waits. The server only wakes up when Telegram actually sends the update. The downside of this approach is that you need a public URL and HTTPS connection. That makes things a little bit more complicated for local development. However, you can still use tools like ngrok and similar tunneling tools to expose your local bot to the internet while you're developing. We're going to cover all of this in future episodes, so don't worry if you don't fully understand how the tunneling works yet. So which one should you actually choose? Well, for development purposes on localhost, long polling is usually the best choice. It is very easy to set up, it works out of the box, and you don't need any extra tools. For production environment, using polling is still totally fine, especially if your bot is small and it doesn't handle a huge amount of traffic. However, webhooks are much more scalable and generally the better choice once your bot grows. There is one more important point here. Serverless infrastructure doesn't really support long polling. You can properly use polling with things like AWS Lambda or Google Cloud Run. The reason is that serverless services are idle most of the time and they have built-in timeouts. So they cannot simply sit there and ask the Telegram API forever. At some point, the platform will just shut them down. So if you need a cost-efficient serverless setup, for example, on AWS Lambda or Cloud Run, you will need to use webhooks. The trade-off here is that you introduce a bit of latency because your serverless instance has to spin up every time when a request comes in. But even then, the overall latency for long polling is usually slightly higher than for the webhooks because with the long polling, there is always a time window between your server asking for a new update and actually receiving this new message. We're going to discuss these trade-offs more in our future episodes and go deeper into those details. But for now, we're going to stick with long polling because it is very easy to set up and lets you focus on writing your bot's business logic and learning the basic concepts instead of dealing with the infrastructural part. And don't worry, setting up webhooks is not much harder, and we'll definitely cover that later in our course. Now that we have cleared up the differences between long polling and webhook, let's move on to the second part of our video. On our next slide, we'll start restructuring our project a little bit. We will introduce routers, clean up the structure, and make our bots easier to extend as it grows. Alright, so what is a spaghetti code? Spaghetti code is the code that is all tangled up. Everything is mixed together in one place, with no clear structure. When you read it, the execution flow jumps around like a plate of noodles, and it becomes very messy and hard to understand, change, or extend safely. The main problem with spaghetti code is that it actually becomes a monolith, a big ball of mud. For example, if you have 500 lines of code or more into a single main.py file, your bot becomes almost impossible to navigate. It is really hard to maintain, and it is painful to scroll through all those lines and find the exact part you need to change. So spaghetti code is also very hard to debug. When you mix different kinds of logic, admin features, user commands, payment flows, whatever, all in the same place, you'll start getting box and variable soup where everything depends on everything else. Really hard to maintain. On top of that, it makes it harder for other team members to help you. If everything is one huge file, can't comfortably work together on the same features at the same time without constantly stepping on each other's toes and dealing with merge conflicts. The more tightly interconnected the code is, the harder it is to maintain as the project grows. That's why I prefer a more professional modular approach. Instead of putting everything into one single file, we split the bot into logical modules. Then we'll split it even further into separate features. You can see here that inside the handler folders, we create separate modules for user-related commands, admin-related commands, payment, and etc. Each file is responsible for a specific feature and contains its own small, isolated piece of logic. And that's basically a feature-based modular approach, each module focused on one area of your bot. It is easier to read, easier to test, and much easier to change without breaking everything else. And that's basically it. That's the core idea behind avoiding spaghetti code and moving toward a clean, modular approach. On the next slide, we'll take this idea and start restructuring our bot project in practice. We're going to add routers and organize our files so the bot scales nicely as it grows. So on this slide, you can see that instead of using the dispatcher directly to register all our handlers, we first create a router object. A router is basically a small focused dispatcher. It groups together a specific set of handlers that is responsible only for a particular area of your application, like user commands, admin commands, or payments. So step number 1, we create a router object that will handle a specific set of tasks. Step number 2, we connect this router to our main.py file. Inside main.py, which is responsible for launching our application, as you might get it from our previous episode, we take the dispatcher we created there and include our router into it. And by doing that, we register all internal handlers that belong to this router and make them active in our application. You can include as many routers as you want. If your bot grows in size and you introduce new features, it is easy to create just another router and hook it up to the dispatcher. So that's just a basic idea I want you to take away from this video. Alright, now that we have covered all theoretical part, let's jump into the implementation and actually set this in the code. Alright, so I'm inside my Visual Studio Code, and here we have basically the copy of the project lesson number 1. Here we have the main.py that we have created in our previous episode. So the first thing that we have to do here is refactor our code a little bit. For this purpose, I'm going to create a new file, which is going to be called handlers.py. And in this handlers.py, I'm going to create a new router object that I'm going to hook up to our dispatcher. I'm going to speed up this video a little bit so you could see the process of coding. And once I finish, I explain you step by step what is going on here. Alright, so here we go. We have 2 simple commands. The first one is command start that I just copy pasted from our main.py file. The second one is command help, which is responsible for handling command help, obviously. As you can see, we can insert emojis here, and this is gonna work without any problems. It supports emojis, it supports Markdown and HTML, and I'm going to show you later how to set this up with HTML specifically. So the second part that we have to adjust here is to go back to our main.py, remove this handler because we don't need this anymore, and adjust our logic a little bit. We don't need a text message any longer, so we have to remove that. And the only thing that we have to change here is to import our router object from handlers and link it directly to our dispatcher. Alright, as you can see, I have just imported the router object from our handlers and just directly registered that using method include router. For more reference, you can always check out the official Aiogram 3 documentation. Now let's go ahead and try testing this bot and see how that works. As you can see, I've already activated the virtual environment and I've already set up all the files and configuration of this project in our previous episode. If you didn't see this video, please feel free to jump back there and follow along from that one. But here I'm going to focus mainly on restructuring. Python main.py is starting polling that we have just discussed, and now we can open Telegram and hit the start command. I'm gonna start this, and as you can see, here's the message. Everything seems to be working, but now let's try to use help command. And here we go. Our emoji, our command, our message, everything seems to be working. Nice. So we have just restructured our project, making it more modular and easier to maintain, easier to understand and navigate through, which is a good step forward. But now let's make one more minor adjustment and just enable HTML Parse Mode so we could add HTML formatting into our messages. So how to handle this? To implement that, you need to import default bot properties from Aiogram 3 library. So this is essentially a way of saying, hey, let's fall back to default properties except parse mode. The parse mode should know HTML. Now let's try to add some HTML markup. For this purpose, I'm going back to our handlers.py nearby the end. Here I'm going to unwrap our help into bold text tag. And I'm also going to unwrap our start command with a code block, so it looks like monospace code. Now I'm going to restart our bot so we could see the difference. Now let's try our command help again. And as you can see, our help is now bold and our start command has a monospace code block wrapper around it. So it looks like a command now, which is pretty cool style adjustment. The only problem with this approach is that if you click on it, it is now just copied to your clipboard and it doesn't send the actual command. So that may be a problem for most users. That's why you have to be careful with this markup. Let me just open that and adjust this to be something like Here we go. Let's try this again. As you can see, start command. And now it is clickable, and we can simply click on it. And that will send start command, and our bot responds with, "Hi, this is our first Aiogram 3 bot." Alright, that wrapped the things up for today's video. I really hope you found this video helpful, and if you enjoyed this video, feel free to subscribe to the channel and hit the like button. And if you have any questions or suggestions to this video, feel free to leave them in the comment section below. Also, don't forget that we have our own Discord community, which is pretty small, but I'm working on growing it. And thank you for watching this video. See you in the next one. Bye!